Hi guys, welcome to PW Gulf YouTube channel. This side Vishali Chaudhary, your chemistry educator. So NEET 2025 is done and I know the level of the question paper was quite good. According to the students' feedback, I got to know that physics portion was quite tricky and lengthy, chemistry was moderate. So if I talk about, like, I also solved the question paper and I found that out of organic, inorganic and physical chemistry, your inorganic was difficult. The statement based questions asked from inorganic chemistry, they were quite tricky, wherein student they have lost their marks. So if you found the paper tough, don't dishearten yourself. Every challenging situation is part of your growth. In this video, I will be discussing all the 45 chemistry questions and will be giving you quick explanation. And so whether you are learning from this attempt or you are just checking your answers, stay tuned till the end. So let's start without wasting much time. I have to quickly answer all the questions and explain them. So here is the very first question, which says if the molar conductivity of a 0.05 mole per liter solution of a monobasic weak acid is 90 Siemens centimeter square mole inverse, its extent of dissociation will be. But here you have to find out alpha, which is degree of dissociation. Alpha. So alpha, you know that alpha we calculate as lambda m upon lambda m naught. In this question, they have given you lambda m, molar conductivity of a weak acid, monobasic acid is this, that is 90 Siemens centimeter square mole inverse, and its extent, and also if you want to find out lambda m naught, so what you will do, because it is a weak monobasic acid, so you'll add molar conductivities of cation and anion. So lambda m naught you will find out as lambda m naught will be equals to lambda m naught of cation, which is 349.6, and anion, which is 50.4. So you'll get the value as 0, 1, 0, 1, 0, 400. So 90 divided by 400. So this value, you'll get this value as 428, 2.25 upon 10, which is 0.225, 0.225. So that is why here option 4 is the right answer. So with this question, I'll keep this question in the category of easy question because it was direct. You just have to find out alpha. So this question was easy. It was easy. Okay. Next, let's quickly move towards the next question. Next question here says, given below are two statements. Statement 1, a hypothetical diatomic molecule with bond order 0 is quite stable. This statement is totally wrong. Why a molecule having 0 bond order is not stable at all, does not exist. So hypothetical diatomic molecule with 0 bond order is quite stable. This is totally wrong. As bond order increases, the bond length increases. Bond order, if it is increasing, your bond length decreases. But this statement is also wrong. So that is why both statement 1 and 2 are false. Option 3 here is the right answer. So this question, like I'll keep this question also in the easy category. Nothing difficult asked here. Next question. This is from structure of atom. Question here says the ratio of wavelengths of light absorbed by a hydrogen atom where it undergoes transition from n is equals to 2 to 4, 2 to 3 and 4 to 6 transition respectively. Beta, you have to find out the ratio of wavelengths in these two transitions. So for you know the formula. What is that formula? 1 upon lambda is equals to 1 upon lambda is equals to RH 1 upon n1 square minus 1 upon n2 square. So n1 square would be here 4. This is lambda 1 minus 1 upon 9. So you'll get it as 1 upon lambda 1 is equals to RH. 9 minus 4 would be 5. So lambda 1 is equals to 36 upon 5 RH. Now if I talk about the second transition, in case of second transition, 1 upon lambda 2 is equals to RH 1 upon 16, that is 4 square 16 minus 1 upon 36, and 1 upon lambda 2 is equals to RH 16, 36 minus 6 would be your 20. Now lambda 2 we can write as 16 into 36 upon 20 RH. Now you can divide the two. This is your 1 and this is your second. So first divided by second, what you will do here, lambda 1 upon lambda 2. Now when you will divide lambda 1 by lambda 2, RH will cancel out. 36 upon 5 into 20 upon 16. 16 into 36. 36 will cancel out, and 5 4 4 4 16. So lambda 1 by lambda 2 is coming as 1 by 4. So yes, here option 1 is the right answer. This was from structure of atom. It was also a direct formula based question. Next one we have is the next question. Next question here says that correct order of wavelength of light absorbed by the following complexes is. You have to find out the correct order of wavelength of light absorbed. So beta, you have to choose from the correct option. They're talking about wavelength of light absorbed, and you know that wavelength of light absorbed, that is inversely proportional to CFSC, crystal field splitting energy. If your ligand is strong field ligand, in case of strong field ligand, your CFSC would be more. If your CFSC is more energy, has the formula Hc upon lambda, so your wavelength would be less. So we can say that CFSC and wavelength, they are inversely proportional. Wavelength, they are inversely proportional. So in which case the ligand is strong field ligand. Of course, out of all of them, strong field ligand is Cn. In case of Cn, your CFSC would be maximum and your wavelength would be minimum. So in this case, B would be having minimum, B minimum, okay, and CFSC is maximum, wavelength is minimum. After that, we have A complex, because ammonia is then your strong field ligand, but it is before Cn. So after that, you have BA. That means here option D is the right answer. And if I'll talk about these two here, what is a weak field ligand? And out of the two, this is the octahedral complex and this is your tetrahedral complex. Out of octahedral and tetrahedral complex, your tetrahedral splitting is almost half of your octahedral complex. So of course, splitting here would be minimum and wavelength would be maximum. So yes, C is having the maximum, and then you have D. So option third here is the right answer. Let's move towards the next one. Next question, this is from chemical kinetics. If the rate constant of a reaction is 0.03 second inverse, how much time does it take for 7.2 mole per liter concentration of reactant to get reduced to 0.9 mole per liter? So, you can have a look here. Rate constant unit is second inverse. That means the order of the reaction is first order. Okay. So, rate constant is given, K is given to you as 0.03 second inverse. You have to find out the time. So, for first order reaction, you know the formula. T is equals to 2.303 by K log of initial upon final. Beta, initial concentration is, here is 7.2. 7.2 divided by 0.998. So, and K value is 2.303 upon K. K value is 0.03, and we can write log 8 as log 2 cube, which we will write as 3 into log 2, and log 2 is 0.3, which they have given in the question as well. Now, this would be 0.01, and this would be 0 here. Yeah, now you can multiply it with 3. 23.03 multiplied by 3. So here it would be 3390, 339, 326, 69.09 second. So that is why here option second is the right answer. Let's move towards the next one. This question is from purification techniques. Match list 1 with list 2, and it was a direct question. Nothing to solve over here. You know that chloroform and aniline, they have difference in their boiling point, so they can be separated by your simple distillation. So A option is matching with simple distillation, A option is matching with 4. That means option second or third can be the answer here. Crude oil in petroleum industry, that is separated by fractional distillation, so your B is matching with third. Now glycerol from spent light, that is separated by distillation under reduced pressure, and so C is first, that means option 1. And aniline water, that is separated by steam distillation. So yes, option number second is correct over here. Next one. Major product of the following reaction is, beta, here in this one, they are treating this compound which is having CO group as well as CN group with excess of Grignard reagent, that is CH3-MgBr. So, like here you will be carrying out the reaction of Grignard reagent with CO group as well and with CN group as well, right? So, let's do it one by one and let's write the product. So, here you have, this is your benzene ring. You are carrying out its reaction. This is C double bond O, C triple bonds N, right? So, first you will be carrying out its reaction with CH3-MgBr. CH3-MgBr, this is positive and this is negative. So, of course, this is gonna attack here. This will attack here. And what you will get, I'm writing first, I am carrying out the reaction first with CO group. So, what you will get is, let's write it down quickly. We'll get it as COMgBr and here CH3. Similarly, the reaction will take place with CN group as well. So here C. Now this is negative and this is positive. Out of the two, this is electronegative. So CH3 minus will attack here. And what you will get is CH3 double bond NMgBr. NMgBr. Now when you will carry out its hydrolysis, MgOH-Br will remove, and what you will get the product as C double bond C CH here, CH3 here, and this is your OH group, C CH3, and here C double bond O. So of course, which option is correct over here? It is matching with which of the following option? This is matching with option number 3rd. So option 3rd here is the right answer. Okay. Next question. Which one of the following compounds can exist as cis-trans isomers? Cis-trans isomerism is shown by the compounds those who show GI, geometrical isomerism. So out of the 4 options, let's find out. GI, geometrical isomerism, is shown by the compounds where the carbon atom is linked with, if it is an alkene, so doubly bonded carbon atom should be linked with different alkyl groups. And if it is your cyclic ring, so that carbon should be linked with your different groups. If I'll talk about option number 1, you have 1,2-dimethyl cyclohexane. This is your cyclohexane, and at first position you have CH3 group, and at second position you have CH3 group. Of course, this is gonna show geometrical isomerism. This carbon is having different groups, hydrogen here, and this is also having different groups. So of course it will show geometrical isomerism. Option 1 here is the right answer. Why not by second, third or fourth? Because in second you have pent 1-ene, wherein at 1, 2, 3, 4, 5, at the first position you have 2 similar groups attached, right? So this is not gonna show GI. You have 2 methyls hex 2-ene, 1, 2, 3, 4, 5 and 6. At second position you have methyl and hex 2-ene. Here also you can see with doubly bonded carbon you have similar groups attached. That is not gonna show GI. You have 1,1-dimethyl cyclopropane. Cyclopropane is this one, and at first position you have methyl group, CH3 group and CH3 group. Of course the groups are same, so it is not gonna show GI. Option 1 here is the only answer. Next one. Among the following, choose the ones with equal number of atoms. You have to find out the one which has equal number of atoms. So beta, in case of molecules, how do you find out number of atoms? There is a simple formula. What is that? That number of atoms is equals to number of moles into Avogadro number into atomicity. Atomicity. If I'll talk about the first one, if you'll calculate n for this one, so n here would be equals to 212 divided by 106. 212 divided by 106 is going 2 times. 2 Na into atomicity here is 2, 3 and 4, 7. 3 atoms here and 3, 7, that is 14 Na. 14 Na. Okay. After that we have 248 gram of Na2O. So number of atoms you can find out. 248 divided by your 62. How many times it is going? 3 times. Sorry, 4 times. It is 4 Na, and into atomicity. Atomicity here is 3. So it is 3. Now this is 12 Na. Okay. Yes. Next we have is the C part, where number of atoms you can calculate as 240 divided by your molar mass, which is 40. It is going 6 times 6 Na into atomicity. Atomicity here is 3. So 3, 6, 18 Na. Okay. Next, here we have the D part, where number of atoms can be calculated as 12 divided by molar mass is 2. Na into number of atoms are 2. So it is 12 Na. 12 Na. Next one, E part, number of atoms can be calculated as 220 divided by molar mass, which is 44, and this is going 5 Na into number of atoms are 3, 15 Na. So which of the following has equal number of atoms? Equal number of atoms are present in your B and your D. So B, हमने कहीं गलती कर दी क्या? I think we have made some mistake here. If I'll talk about 212 divided by 106, so it is going 2 times 2 Na into 2, 3, 4, 5, 6. Acha, this is 6, guys. This is 6, not 7. Here it is 6. It is 6 and 6 to 12. That is why here it is 12 Na. This is 12 Na. So here we have A, B and D. So A, B and D, that means option third here is the right answer. Okay. Next one, guys. Next question here is, among the given compounds 1 to 3, the compounds, the correct order of bond dissociation energy of carbon hydrogen bond marked with star is. So in this question you have to find out which bond is strong. The one which has more strong bond would be having more bond dissociation energy. So if I'll talk about this one, but this carbon is sp2 hybridized. This is sp2 hybridized. This carbon is triply bonded, so it is sp hybridized. And here this carbon is singly bonded, so its hybridization is sp3 hybridized. Of course, out of the 3, sp hybrid orbital that has more percentage as character, more electronegative, will be holding the electrons more tightly. So bond here would be more strong, this carbon hydrogen. So here we have second, then we have the first one, and then we have the third one. So yes, second, first and third. So yes, here option second is the right answer. Next one. The standard heat of formation in kilocalorie per mole of barium plus 2 is. You have to find out standard heat of formation of in kilocalorie per mole. Standard heat of formation of SO4 minus 2 is given. Heat of formation, standard heat of crystallization when BSO4 is forming, that is given, and heat of formation of BSO4 is also given. Let's write down the equation first. Barium plus 2 and SO4 minus 2. They are reacting with each other and are forming barium sulfate. In this reaction, the amount of heat, the amount of that is, they have given standard heat of crystallization when BSO4 is crystallizing, the heat released is minus 4.5 kilocalorie per mole. So you have to find out enthalpy of formation of barium plus 2 ion. Barium plus 2 you have to find out. Yes. So we can write enthalpy of reaction is equals to enthalpy of formation of your BSO4 minus enthalpy of formation of barium plus 2, enthalpy of formation of SO4 minus 2. But this is already given to me for 4.5 minus 4.5. This is also given to me formation, that is minus 349. And barium I have to find out, minus delta HF naught, barium plus 2, and SO4 minus 2 they have given us, that is minus 216, which will be plus 216. Now if you, let's solve it. Delta HF naught of barium plus 2, that is will be equals to minus 4.5 plus 349 minus 216. Now let's solve it. Jaldi se solve karo and batao. Tell me what is the answer coming. Minus 4.5. The value is coming as 128.5. 128.5, and this value would be negative because here there is minus sign. So yes, here option second is the right answer. Okay. Next one, guys. But this was one of the easiest question. Consider the following compounds. In these compounds, you have to find out oxidation state of underlying elements. You know that potassium has +1. Potassium is a group 1 element. It carries +1 charge. It is a peroxide, so oxygen here would be having -1. Sulfur here is in +6. So yes, which option is correct over here? +1, -1, 6. Option second is the right answer. Next one. Out of the following complex compounds, which of the following compound will be having the minimum conductance in the solution? Now, this is a question where two answers are possible, but again, either two answers are possible and let that and NTA will decide, or according to my choice, I will go with option number second. But why? I'll tell you the reason for that. So minimum conductance. Beta conductance depends on number of ions. Lesser the number of ions, lesser would be the conductance. If I'll talk about these two will give 2 ions. You will be getting 2 ions here because this will ionize to be positive and negative. 2 ions. In this case, you will be getting 1 plus ion and 3 Cl minus ions. So here you will be getting 4 ions. But out of the two, in these two cases, because this is existing as a single species, right? If it is a single species, it will remain as it is. They both are single species. So here we can't decide on the basis of number of ions. So that NTA will decide like either like whether they are giving both the answers as correct, second or third. But out of the two, I have one reason behind it. So if I'll talk about the second compound, in second compound, chlorine has -1. So 3 chlorine is having -3. Ammonia does not carry any charge. It's a neutral ligand. Cobalt is having, of course, the compound is neutral, so it should have +3. So compound is neutral. This is neutral. But if I'll talk about the second one, in the second one, chlorine has -1, 2 would be having -2. But you can see that the coordination number here is 6. If the coordination number here is 6, of course, cobalt with coordination number 6 shows +3 oxidation state. So in that case, it will be positively charged species. The conductance of positively charged species would be more. So that is why either option third is correct or both the answers second or third are correct. Okay. Next one. Next question here, which one of the following reaction does not give benzene as the product? So you know that this is your benzene diazoxide chloride, you're warming it with water. So diazoxide salt, it wants nucleophile. So what happens here, that here in this reaction you get phenol. This is not gonna give your benzene. Option 1 is the right answer here. In other options, you will be getting benzene. This is decarboxylation. This is your aromatization. This is again aromatization. You will be getting benzene in the other cases except the one. Next one. Which of the following are paramagnetic? Paramagnetic substances are those who have unpaired electrons. In out of the 5 complexes you have been given, they have given nickel as a central atom. So the one where like there is a strong field ligand will carry out pairing, and if it will carry out pairing, you will not be having any unpaired electron. So weak field ligands, I have solved this question. So in case of weak field ligands like Cl, here it is Cl, which is a weak field ligand, WFL, and cobalt, carbonyl is a strong field ligand, Cl is a strong field ligand, water is a weak field ligand, WFL. So PPH3 again, it is a strong field ligand. So in the two cases A and D, you will not be getting any paired electron. You will be having unpaired electrons. So that is why these species would be paramagnetic. That is why here option A and D are correct. Next one. Which one of the following compounds does not decolorize bromine water? Which does not decolorize bromine water? You very well know that aniline reacts with bromine water to give a white precipitator of 2,4,6-tribromoaniline. Phenol, if I'll talk about phenol, gives a white precipitate of 2,4,6-tribromophenol. And this is, of course, it is an alkene. It will decolorize bromine water. All the alkenes, this is used as a test for unsaturation. This is a compound that is not going to decolorize bromine water. It is not having any double bond. Next. Match list 1 with list 2. Choose the correct answer from the options given below. But in this question, Haber process. In Haber process, that is used for the preparation of ammonia. Nitrogen reacts with hydrogen to form ammonia, where we use iron as a catalyst. So in Haber process, we use iron as a catalyst. In Wacker oxidation, we use PbCl2 as a catalyst. In Wilkinson catalyst, we use PPH3 RHCl, rhodium chloride. Ziegler catalyst, Ziegler-Natta catalyst is PiCl4 with trimethyl aluminium. So here all the options are matched. So A1, B2, C3, D4, option 4th is the right answer. Next one, match list 1 with list 2. Beta, this was a direct question from your biomolecules, vitamins. Vitamin B12, B. So here option 3rd is the right answer. Option 3rd, B12 with 4 and B, that is D with 3rd rickets, and the C with first one chylosis, and then D with second one convulsions. So option, this was a direct question, nothing to explain here. Next one, next statement. This was a statement based question. It was quite tricky. Like here the question is saying, inorganic say, statement 1, ferromagnetism is considered as an extreme form of paramagnetism. This statement is totally true. Ferromagnetism is considered as an extreme form of paramagnetism. This is totally true. Number of unpaired electrons in chromium plus 2 ion is the same as that of Na3 Nd. This is not Na, this is Nd. This is a correction here. 3 positive ion. So this statement is not correct because the number of unpaired electrons in chromium plus 2 are 4 and the number of unpaired electrons in Nd plus 3, they are 3. So they are not same. This statement is wrong, but first is correct. Statement 1 is true, second is not true. So 1 is true, second is false. So option 3rd here is the right answer. Next one. If the half-life for a first order reaction is 1 minute, first order reaction half-life is given, then the time required for 99.9% completion of the reaction is closest to. So beta, this is direct question. You can simply use a formula here. Time you have to find out, and for first order reaction it is 2.303 by K log of initial by final. Initial I am assuming 100% and the final, like the reaction is 99.9% completed, so remaining would be 0.1. In place of K, how do we calculate K for your first order reaction? That has the formula K is equals to 0.693 by T half. And T half value is given as 1 minute, that is 60 seconds. So 2.303 upon 0.693 into 60. This is, we can write it as log 10 to the power 3, that is 3 log 10, log 10 is 1. So 326, 339, 31. Now this is going approximately 10 times. It is coming as 600, that is 10 into 60, but this time is coming in second. You have to convert into minutes. If you want to convert it into minutes, so you'll be dividing it by 60 and you will get the answer as 10 minutes. So 10 minutes is the right answer here. Option 1 is correct. Next one. The correct order of decreasing basic strength of given amines. So the question here says, you have been given different amines. Let's write the structure. With the help of structure, you'll be able to solve this. You have benzene amine. I'm drawing the structure here. Benzene amine, which is aniline. NH2 present on benzene ring. Okay. Where lone pair participates in resonance, so its basicity decreases. You have ethanamine, and then you have N-methylamine. If I'll talk about N-methylamine, this is your N-methylamine, NHCH3. So here there is one CH3 group which is donating electrons to the nitrogen atom. Here also nitrogen participates in resonance, but its basic strength would be more as compared to aniline because CH3 plus I effect. Next we have is N-ethylethanamine and ethanamine. We have ethanamine. Ethanamine is CH2, CH3, NH2. This is ethanamine. And then you have N-methylethanamine and ethylethanamine, that is C2H5, NHC2H5. Beta, here to this nitrogen, here nitrogen has lone pair. Nitrogen has lone pair. Its basic strength would be maximum. Why its basic strength would be maximum? Because of the 2 plus I effects. There is an increased electron density on the nitrogen, while here there is only one electron donating group, increasing electron density on nitrogen. Here, so this is the increasing order of their basic strength. So ethanamine the top, ethanamine, N-ethyl ethanamine the top. Then you have ethanamine, and then you have benzenamine. No, benzenamine nahi. Second will not go. Fourth option will go. N-ethyl ethanamine, ethanamine, N-methyl ethanamine, and benzenamine. Here option fourth is the right answer. Next one, let's move ahead. Choose the correct answer from the options given below. So this is from practical organic chemistry. What, like, you do analysis for cations 0, group 1, group 2 until 6. So for this one, aluminium lies in group 3rd. Aluminium lies in group 3rd. D is matching with second. D is matching with second. That means option 3rd here is the right answer. Your lead lies in group 1. So C is matching with 1. Your D, magnesium lies in group 4. Magnesium lies in group 4, and then your cobalt, magnesium lies in, here it will be group 6 beta. There is a correction here. I think there is a typing error here. It should be group 6. Group 6. Magnesium lies in group 6, and then what remains is your cobalt, which lies in group 4. So yes, here option number, क्या किया हुआ है इन्होंने यहाँ पे? C, D is matching with second. Your lead is matching with group 1. D is matching with 4th. ठीक है. Now option 3rd is correct over here. Next one. Okay. So here this is from equilibrium, which says phosphoric acid ionizes in 3 steps with their ionization constant values K1, K2, K3. While K is the overall ionization constant, which of the following statements are true? So phosphoric acid, that is H3PO4. H3PO4 ionizes in 3 steps because it has 3 H plus ions which it can donate. So in first step it will be donating 1 H plus ion. That is, it will form H2PO4 minus after loss of 1 H plus. In second step, H2PO4 minus will be losing the second H plus ion and will form HPO4 minus 2 after loss of second H plus. Then in the third one, HPO4 minus 2 will lose PO4, will form PO4 minus 2 after the loss of PO4 minus 3 after the loss of 1 more H plus ion. So for the 3 steps, like for the first one it is K1, this is K2, and this is K3. Yes, for the overall reaction, your K will be equals to Ka1 into Ka2 into Ka3. So if you will take the log K will be equals to log K1 plus log K2 plus log K3. So statement 1 is correct. H3PO3 is a strong acid than H2PO4 minus. That is true. Your ionization, most of the ionization takes place in the first step only. This is also true. K1 would be greater. Yes, K1 would be greater than K2 and K3. That is also true. Option D is not correct here. Statement D is not correct here. So A, B and C. That is option 1 is the right answer here. A, B and C. Next one, guys. Which of the following statements are true? Which statements are true? Unlike gallium that has a very high melting point, has a very low, has a cesium. Here it will be cesium. Cesium is it is cesium, guys. Cesium has a very low melting point. This statement is totally wrong because gallium has low melting point. It is mentioned in NCERT as well. On Pauling scale, the electronegativity value of nitrogen and chlorine are not the same. No, they are same. The value is around 3. This statement is wrong. Argon, potassium, Cl minus, they all are isoelectronic species. Yes, they all have 18 electrons. So they all are isoelectronic species. Correct order of first ionization enthalpy of sodium, magnesium, aluminium, silicon is, beta, you have sodium, magnesium, aluminium, silicon. Sodium, magnesium, aluminium, silicon. So here your ionization in a period, your ionization and enthalpy increases when we move from left to right. But here, like you have studied in a second period, there is an exception that beryllium has more ionization enthalpy as compared to boron. Similarly, here the ionization enthalpy of, as we move from left to right, your silicon, then you have magnesium, and then you have aluminium, and then you have sodium. This is the decreasing order of their ionization enthalpy. So this statement is totally wrong. This statement is totally wrong. So here, which option is correct? Statements which are true. So on Pauling scale, the electronegativity, unlike gallium, that is, this statement is wrong. Pauling scale, the electronegativity value of nitrogen and chlorine are not the same. But like the values are, if I'll talk about nitrogen, it is 3, and for chlorine, it is 3.1. Okay. And this is also the correct order of ionization enthalpy. Silicon, aluminium, that is wrong. So here, which option is correct? Option C. यहाँ पर क्या गलती हुई है? Correct order of first ionization enthalpy of sodium, magnesium, aluminum is this. Silicon, magnesium, but this is not correct. This is wrong. These all are isoelectronic species, that is true. Unlike gallium has very high, this is wrong. On Pauling scale, the electronegativity. True बोला है कि question. Wait. Let me check the question here. I think कुछ तो typing error हुआ है. Wait. Wait, guys. Give me a minute. There is one statement which is missing over here. E statement is missing over here. So let me write that statement. मैं लिख देती हूँ. I'm writing that statement because that is missed. I think कुछ typing error हो गया है. So statement E is atomic radius of cesium is greater than that of lithium and rubidium. So cesium is an element of group 1 and it is the bottommost element. So, and you're moving from top to bottom, your size always increases. So this statement is true. That means here your options C and E are correct. That is option number 3rd is the right answer. Option number 3rd is the right answer here. Next one. Given below are two statements. Statement 1, like nitrogen that can form ammonia, arsenic can form arsine. Yes, nitrogen can form ammonia and NH3, and arsenic can form arsine, that is ASH3. This is true. Antimony cannot form antimony pentoxide. No, antimony can form antimony pentoxide, SbO5. Sb2O5 exists. That is, but they are saying cannot form. So this is wrong. Statement 1 is true. Statement 2 is wrong. 1 is true and 2 is wrong. Which option will go? Option number this one, 4th one, true, but statement 2nd is correct. Okay, next. Which of the following aqueous solution will exhibit highest boiling point? Easy question. Highest boiling point. Beta, you very well know that boiling point, that is equals to I into Kb into M, right? Here you have been given the concentration I value. So if I'll talk about this one, in case of this one, your delta Tb would be equals to, I value here is 1 because it is a non-electrolyte, 1 into 0.015. Okay. If I'll talk about the second one, delta Tb is equals to urea. I value is 1, non-electrolyte 0.01. For this one, delta Tb is equals to I value for KNO3 plus 1 and minus 1. 2 ions you will be getting, 2 into 0.01. So here delta Tb is equals to 2 Na positive and 1 SO4 minus 2. So in total, you are getting 3 ions, 3 into 0.01. It is maximum for option 3rd. That is why option 3rd here is the right answer. Next one, guys. Given below are two statements. Statement 1, benzene diazonium Salt is prepared by the reaction of aniline with nitrous acid at 273 to 278 Kelvin. It decomposes easily in the dry state. This statement is totally true. We prepare benzene, diazone, and salt by carrying out reaction of aniline with NaNO2 and HCl, NaNO2 and HCl, maintaining temperature of 0 to 5 degrees Celsius. Then we get C6H5 N2Cl. N2Cl. And this is also true that it decomposes easily in the dry state. It is explosive in the dry state. Statement second says insertion of iodine into the benzene is difficult and hence iodobenzene is prepared through the reaction of benzene diazone salt with KI. This is also true. We carry out this reaction with KI because I1 is the nucleophile and diazone wants nucleophile. So it forms iodobenzene. So both the statements are true here. And statement 1 is true. Both the statements are correct. Next one. Identify the suitable reagent for the following conversion. This is easy, guys. This is ester, you can see. RCOOR. This is ester. And ester is converted to aldehyde. So, of course, you will be using Dibal. So, yes, option third here is the right answer. Next one. Given below are two statements. One is labeled as assertion, another is reason. Assertion says this is your alkyl iodide undergoes SN2 reaction faster than this chloride. This is totally true and this is easy because iodine is a better leaving group. So yes, because of its large size, assertion is correct, reason is correct, and reason is very well explaining assertion. So here option second is the right answer. Both are true and reason is the correct explanation of assertion. Next guys, the correct order of decreasing acidity of following aliphatic acids is beta acidic strength. If you will look into this question, the compounds that have been given to you. So here CH3 groups are attached. CH3 groups, they are electron donating groups, and if your electron donating groups are there, your acidic strength decreases. Electron withdrawing groups increases the acidic strength, while electron donating groups decreases the acidic strength. So acidic strength is inversely proportional to electron withdrawing groups. More electron withdrawing groups, less would be the acidic strength. So here the compounds that have been given to us, HCOH. In HCOH, beta, here there is only one CH3 group. Its acidic strength would be maximum. After that we have CH3COH, CH3C double bond OOH. There is one, you can see there is one CH3 group. After that you have CH3CH3. Two CH3 groups attached with the carbon, CH3, C double bond OH. Of course, its acidic strength would be even less as compared to 3 degree 1, wherein CH3, C, CH3, CH3 and C double bond OH is there. So here you have two electron donating groups attached, here you have three attached, more electron donating groups. This is donating groups, beta. EWG nahi hai. Here it is EDG, electron donating groups. So yes, here which option is correct? Option number 4 is the right answer here. Next one. Which one of the following reaction does not belong to Lassagne test? Beta, Lassagne test we use to Lassagne extract we prepare to convert organic compound into its ionic form so that we can carry out the analysis. So where we treat the organic compound with sodium and we heat it. So organic in Lassagne extract, like the element present can be halogen, can be sulfur, can be nitrogen. All these three reactions are applicable for Lassagne test, but this is not at all applicable. Option 1 is the right answer here. Next one. How many products, including stereoisomer, are expected from monochlorination of the following compound? Beta, you are carrying out monochlorination and the number of products that you get in monochlorination, that is equals to the number of different hydrogens, right? And they are also talking about including stereoisomers. Okay, beta, these two carbon atoms, they are same. So you will be here, you will be getting four products, one product when you will remove hydrogen from here, when you are carrying out reaction with chlorine, Cl2 in the presence of sunlight. So you'll get Cl, CH2, and then you have CH, CH3, CH2, and then you have CH3. So this is your one product. These two are same. Second product you will get is this one, CH3, CH3, Cl and CH2 and CH3. After that you have the third one, wherein third product you will get CH3, CH, CH3 and CHCl, and this is your CH3. The fourth product that you will get would be this one when hydrogen will be removed from here. So CH3, CH, CH3, CH2, CH2, Cl. These are the four products, monochlorination products that you are getting. Now, here, out of all of them, if I'll talk about this carbon, this is not optically active because this is not chiral carbon. This is not chiral carbon because of groups are not different. This is chiral carbon because with this carbon, all the groups attached are different. So we'll be making one enantiomer of it by putting a mirror. So yes, one more enantiomer, and so in total, but this is not chiral. So in total, you'll be getting total 5. So option number 4 here is the right answer. Next one, sugar X is found in honey. Okay, there is a sugar that is found in honey, is a keto sugar. A sugar is made up of glucose and fructose, and out of the two, your glucose that has aldehyde group, but fructose that has keto group. So exists in alpha beta anomeric form, that is levorotatory. So the direct answer here is fructose. It is fructose. Next one, Dalton's atomic theory could not explain which of the following? Beta, Dalton's atomic theory could not explain law of gaseous volume. That is a direct question. Next one, high yield of NO in N2 plus O2 is giving 2NO can be obtained at. Okay, so you can see this reaction here. For this reaction, delta H is it is an endothermic reaction because delta H is positive. Enthalpy of the reaction is positive. Choose the correct answer from the option below, like what you will do to maximize the yield of NO. So what you will do, if you will increase the temperature, according to Lee-Chandler principle, your reaction will try to decrease. And if it will try to decrease, how it can decrease the temperature? When it will move in forward direction. So higher temperature, this is correct. Lower temperature, when you will decrease the temperature, your reaction will try to increase and it will move in backward direction. In that case, NO yield will decrease. Higher concentration of N2, yes. If you will increase the concentration of N2, of course, equilibrium will disturb. Your reaction will try to decrease the concentration of N2 and it will move in forward. So by increasing the concentration of any of the reactant, your NO yield will increase. So A, C and D, they are the right answer, option 1. Next one. Next question we have is match list 1 with list 2. But it was easy, VSEPR theory. They're asking you XeO3 hybridization and its shape, they are asking. So that you can find out very easily by using steric number. If I talk about XeO3, let's find out its steric number. Z is equals to half V plus M minus C plus A. There is no cation or anion. So half V. Here is valence electrons of xenon are 8. There is no monoatomic ion here. So it will be 4, and 4 means hybridization here would be sp3. And if I talk about its shape, so it will be pyramidal. So here option 1 is matching with second. Okay, so that means option second or third can be the answer. Next we have is XeF2. In case of XeF2, guys, XeF2, let's find out Z. Z is half, 8 plus 2, monoatomic atoms are 2. So it would be 5. So hybridization here will be sp3d2. sp3d, not d2. So in case of sp and xenon, of course, it would be having linear shape. Other lone pairs will remain at equatorial positions. This is your XDF2. So your option B is matching with first. B is matching with first option. Again, 2 or 3 can be answer. Let's talk about the C part. In case of C, you have XeOF4, and in XeOF4, let's find out Z. Half 8 plus monoatomic atoms are 4, so this would be 6. That means hybridization here would be sp3d2. And if I'll talk about the shape, so XeOF4 would be square pyramidal. This would be, I'm sure the bottom part is visible, so this would be square pyramidal. So yes, it is matching with option C, is matching with 4. So that is why here option number 2 is the right answer. XeF6, that is square, this is distorted octahedral. So D is matching with 3rd, and its hybridization would be sp3d3. Next one, guys. Next we have is match list 1 with list 2. Choose the correct answer from the options given below. Humidity. In humidity, liquid is present in a gas. Alloys, they are solid in liquid. So A is matching with 2nd and B is matching with 1st. Option 3rd is the right answer. Amalgam is liquid in solid and smoke is solid in gas. So yes, option 3rd is the right answer. Next one. Energy and radius of first Bohr orbit of helium plus and Ni plus 2 ion are. Beta, you very well know the formula to find out. Let's calculate energy of Li plus 2 and let's calculate radius of Li plus 2. So, energy, if you want to find out for Li plus 2, which is a hydrogen-like species, the formula is minus 2.18 into 10 to the power minus 18 Z square by N square. Beta, Z value in case of lithium would be 3. Atomic number is 3. So 9 upon N square, they are asking about first Bohr orbit, so 1. Now again multiply 9, 8, 2, 7, 6, 1, 9, 2, 18, 19. 19.6 minus 19.6 into 10 to the power minus 18 joule. Okay. Now let's find out the radius. Radius has the formula 52.9 N square by Z. N value is 1 and Z value here is 3. You can divide it 313 and 721 and 6, 3, 6, 18, 17.6. This is in picometer. So it is coming as minus 19.62 into 10 to the power minus 18. कहाँ है? Which option it is? एक मिनट, ऑप्शन चेक करने पड़ेंगे क्या? It should be 10 to the power minus 18. Li plus 2. Okay, let's calculate it for helium plus. Okay, helium plus I am calculating here. Beta, helium has energy, if you want to find out of He plus, it has atomic number 2. Energy has the formula minus 2.18 into 10 to the power minus 18. Z square. Z value here is 2, 2 to 4 upon N square. This would be, this is the energy which I am calculating. So into 10 to the power minus 18. This is 8, 4, 32, 3, 7, 4 to 8. Minus 8.72 into 10 to the power minus 18. And let's calculate the radius as well. That is 52.9 N square by Z. And Z value here is 2. So 2 to 4, 6, 12, 2, 4, 8 and 5 picometer. So 26.45 picometer. So let's check it which option is correct. मैं एक बार option check कर लेती हूँ. In case of lithium, Li positive, it is 19.62 and radius is 70, but it should be 10. Let me check the option if there is some error. मैं एक बार देख लेती हूँ in the typing. But in the second option, it is not 16, it is 10 to the power minus 18. There is a correction here. In the typing, it is the typing mistake. 10 to the power minus, हाँ, एक second बस. Yes, 19.6 into 10 to the power minus 18, and this is 17.6 picometer. This is minus 8.7 to 10 to the power minus, this is again 18. and this is 26.4 picometer. In the last option, it is 10 is for minus 16. Yeah. So here, which option is going? This is going with option number second. So here, option second is correct over here. Okay. Next one. Which among the following electronic configuration belong to main group elements? Main group elements are your S block and P block elements. This is an element from S block. This is an element from D block. This is from S block. This is the configuration of vanadium. This is from D block because last electron is entering into D. This is an element from P block and it is part of main group element. And then here you have, this is an element from D block. 3D10. Last electron is entering into. This is the configuration of, kiska configuration hai? Copper, which is 29. D block, then it is an element from F block. So here option A and C, they are correct. Option third here is the right answer. Next one. Here in this question, this was super easy question. They have given the value of enthalpy of this combustion, which of the following diagram give an accurate representation of above reaction. Beta, you can see that the reaction is exothermic. And for exothermic reaction, you know delta H we calculate as enthalpy of product minus enthalpy of reactant. If the difference is coming as negative, that means enthalpy of reactant is greater than enthalpy of products. Then only the difference is coming as negative. So here enthalpy of reactant would be more. Option not 1 is not the answer. Second is the answer over here because enthalpy of reactant is more as compared to product by 74.8. That is why option second is the right answer here. This is not correct. Reactant enthalpy is less, and this here they are representing activation energy. This is not right. Next one. Predict the major product P in the following sequence of reaction. In this question, they have given, this is your cyclopentene, and on cyclopentene you have CH3 group attached. First, you are carrying out the reaction of HBr and benzoyl peroxide. So this will follow anti-Markovnikov rule, where negative will go to the carbon which has less hydrogen. So what you will get is, here you are not having any hydrogen, and here there is one hydrogen. So negative will go to the carbon which is having more hydrogen atoms according to anti-Markovnikov rule. So more hydrogen atoms are present here. So yes, CH3 here and Br here. Then you are carrying out its reaction with KCN. When you carry out its reaction with KCN, it will undergo reaction and will form CN. This is CH3. Then you are carrying out its reduction by using sodium amalgam and ethanol. Sodium amalgam and ethanol. So you will get amine. That is CH3, CH2 and NH2. That is why here which option is correct? Option number third is correct over here. Next one, guys. Identify the correct orders against the property mentioned. They're asking you to find out the correct order. Dipole moment. But a dipole moment of water is more as compared to ammonia. Why? Because in oxygen there are 2 lone pairs, and also the electronegativity of oxygen is more. In case of water, oxygen has 2 lone pairs while ammonia has 1, and also the electronegativity of oxygen is more. So its dipole moment would be more as compared to ammonia. And this is your organic molecule CH3L3. This is correct. XeF4, XeO3, XeF2 number of lone pairs of central atom. But in XeF4, xenon has 8 electrons in its valence shell. Out of 8, with 4 it is making the bond. So how many lone pairs will remain? 2 lone pairs. 2 lone pairs. If I talk about XeO3, there is only 1 lone pair. 1 lone pair. If I talk about XeF2, there are 3 lone pairs. So this order is not correct. OH-CH-NO bond length. Beta, you know that when we move from left to right, you have been given carbon, nitrogen and oxygen. When we move from left to right, your size decreases. Size decreases. So what do you think, out of oxygen and nitrogen, who would be having a smaller size? Of course, oxygen. So oxygen hydrogen bond length would be less as compared to your carbon hydrogen, because the size of carbon is more. So this bond length would be more as compared to OH. So this is also wrong. Bond enthalpy. Bond enthalpy depends on bond order. Bond order, more the bond order, more would be bond enthalpy. Bond order of 9, N2 is 3, oxygen is 2, and hydrogen is 1. So this is correct. So yes, here option A and D are answer. Option A and D, second. Next one, guys. Total number of total number of possible isomers, both structural as well as stereoisomers of cyclic ethers of molecular formula C2H2O is. इसमें कुछ correction है. I think ये formula typing error है. Let me check the question. The formula is C4H8O. It is C4H8O. Okay. This was good question. It is, I am saying out of all the question, it is one of the most difficult question out of all the questions of chemistry. So, total number of possible isomers of cyclic ether of molecular formula C4H8O. So, first of all, let's find out degree of unsaturation over here. Degree of unsaturation is equals to C plus 1 minus H plus X minus N divided by 2. Number of carbon atoms here are 4. So 4 plus 1 minus, these are your 8. Hydrogen atoms are 8 divided by 2. 5 minus 4. Degree of unsaturation is 1. That means because they are talking about cyclic ether, there will be one cyclic ring. Okay. Now, with this one cyclic ring, what all structures we can draw? Cyclic ether formula is C4H8O. Let's draw a 5-membered ring. Let's start with the 5-membered ring. So in 5-membered ring, your cyclic ether oxygen will be there, and this is your compound which is having 4 carbon atoms and 8 hydrogen atoms. Second possibility, what is the second possibility I'm drawing here? In one ring we can draw the structure. In 5-membered ring we can draw the structure. Now let's start drawing the 4-membered ring, cyclic ether. Let me draw the 4-membered ring over here. This is second one here, second type, wherein you have 4-membered ring. This is a 1 oxygen atom and 3 carbon atoms are in the ring. Now 1 carbon atom is remaining. So that 1 carbon atom you can attach here, and this, now when you have attached this here, this carbon is now chiral. This carbon is now chiral. It is chiral carbon. Because it is chiral, you can draw its one enantiomer. You can put a mirror and you can draw it enantiomer. Enantiomer, okay. By putting a mirror image. Alright, so this is one. Now another possibility is that in the 4-membered ring, what you can do, you can attach your CH3 here. Now when you have attached your CH3 here, this is not chiral, this is achiral, because here there is a plane of symmetry. There is plane of symmetry. Because of plane of symmetry, here this is achiral and enantiomer is not possible. Now in the 4-membered ring, these two isomers are possible. Let's start with the 3-membered ring. So if I start with 3-membered ring, I have, this is your oxygen and these are your 2 carbon atoms. Now 2 carbon atoms are remaining. One possibility is that I am attaching CH2, CH3 here. Now this carbon is my chiral, because with this carbon different groups are attached. Because this is chiral, now what I can do, I can draw its enantiomer. I'll put a mirror and I can draw its enantiomer. Okay, this is one. Now what is next is that what I can do is that in the 3-membered ring, I can attach 2 CH3s here. 2 CH3 here and CH3 here. This is not chiral, so no enantiomer. Now what I can do next is that I can put the 2 CH3s, one this side, one this side, CH3 here, and another this side, CH3 here. Okay. Okay, this is one enantiomer. This is one isomer. Another possibility is that the two CH3 group, they are present above the plane. Another possibility is that the 2 CH3 groups, they could be present here below the plane. CH3 here and CH3 here. Another possibility here is that the one is present above the plane and one is present below the plane. CH3 and this is your CH3. So these are the possibility. Let's find out how many structures we are able to draw. This is the first one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in total 10 isomers, including both structural as well as stereoisomers, you can draw for this molecular formula. This was one of the most difficult question. Next one. Second last question. For the reaction A is converting to 2B, the backward reaction rate constant is higher than the forward reaction rate constant by a factor of 2500 at 1000 Kelvin. R value is given for the reaction. You have to find out Kp. Let's write down what they have given. They are saying backward reaction constant is higher than forward by a factor of 2500. That means K of backward reaction is equals to 2500 into K of forward reaction, because this value is higher by this factor. So K upon Kb we can write as 1 upon 2500. Yes, which is equals to K, which is equals to equilibrium constant for the reaction. Now you have to find out Kp. So Kp is equals to Kc RT to the power delta N. Kc value is 1 upon 2500. R value is 0.083. Temperature they have mentioned in the question as 1000. And what is the value of delta Ng for this reaction, guys? Delta Ng here is equals to gaseous products minus gaseous reactants 1. Delta Ng is 1 over here. Now this is 1000. This will cancel out. So 83 divided by 2500. Let's divide it and let's get the answer. इसको divide करते हैं. 2500 0.033. 0.033. That is why here option 4th is the right answer. Next one, guys, and the last question. 5 moles of liquid X and 10 moles of liquid Y makes a solution having a vapor pressure of 70 torr. Vapor pressure of pure X and pure Y are this and this. Which of the following is true regarding the described solution? They're asking whether the solution will show positive deviation, negative, ideal, or what. So beta, they have given number of moles of liquid X. Number of moles of X are given as 5. Y are given as 10. Vapor pressure of the solution is given. This is the observed vapor pressure. P naught of X is given. This is P naught of X and this is P naught of Y. So you have to find out whether the solution will act as ideal, positive, or negative. So for that you should find out what is the theoretical vapor pressure. And theoretical pressure according to Raoults can be calculated as P naught A X of, in place of A I'll write X because you have been given, this is X, P naught, and this is P naught. P naught this is mole fraction of X plus P naught of Y into mole fraction of Y. Beta, P naught of X is 63 and mole fraction of X can be calculated as 5 upon total moles, which is 15, plus P naught Y, which is 78, into mole fraction of Y 10 upon 15. Now 5, 3, 3, 2, 6, 3, 1, 3. This is 21 plus 5, 2, 10, 5, 3, 15, 3, 2, 6, 3, 6, 18, 2, 6, 12, 1, 52 plus 21, which is coming as 73. This is coming as 73. Now this is your theoretical vapor pressure, P theoretical, but your observed vapor pressure is your 70 torr. Beta, right now you can see that your observed vapor pressure is less as compared to the theoretical vapor pressure. This is showing negative deviation. Because this is showing negative deviation, that is why here option 3rd is correct. So that's it. That was the last question. So We have solved the complete NEET 2025 question papers. Again, I'm saying that if your paper, you found the paper tough, don't dishearten yourself. Whatever preparation you have prepared a lot for this exam, and if you found it tough, do not worry about that. It was tough for everybody. The question paper was tough. The level of the question paper was good for everybody, not just for you. So of course the cutoff, expected cutoff, we are expecting that it is going to be lower. So don't worry, you have come so far already, and this is just one story. Like this is just one situation. This is just one challenging situation. It is not gonna decide about your future. Of course not. So this is not your whole story. So stay strong, and you have already come so far, and we are so proud of you. Uh, Now, because we have solved all the questions, I would love to know your score in chemistry or your total score, so that you can comment below, and also comment down which question you found the trickiest. So that's it for today. Thank you so much. Take care and bye-bye.